So we will be beginning a new topic, kinematics. So actually we will be dealing with kinematics of a particle, right? First we will begin with kinematics 1D. 1D means it is a straight line motion, that is motion in a straight line. Okay. So here suppose this is the starting point of the particle and this is the direction of motion, or this is a certain axis. Consider it as x axis only. So here at a certain value of time t, this is the coordinate of the particle x. Here is the particle at time t, and after a certain time the particle is here. So this is x plus delta x, I mean the change in x is delta x, and here the time is t plus delta t. So that means at time t coordinate is x, and at time t plus delta t coordinate is x plus delta x. That is, delta x is the displacement of the particle, displacement in the time delta t. Now, so delta x by delta t signifies what? It signifies average velocity of particle, average velocity in the interval, how much? T to t plus delta t, t to t plus delta t. If you make this interval delta t very very small, then you get what? See, this is v average. So if you make this delta t, the interval very small, so if delta t is very small, then delta x by delta t, now I will put a limit, delta t tends to 0, as we have discussed in our basic calculus class. So this is equal to v. Now this v stands for the instantaneous velocity. Instantaneous velocity in or at time t. Instantaneous velocity at time t, or it is velocity in the interval t to t plus delta t, or t plus dt, as delta t is very very small. Okay, so we can write v for instantaneous velocity, v is equal to dx by dt. Okay, now same way we can write the instantaneous acceleration. Instantaneous acceleration a is equal to dv by dt, the rate of change of velocity with time. So now I hope you have gone through the integration lectures. So this dv equal to a times dt. Now let us consider first constant acceleration motion. Okay. So for constant acceleration motion we will do that, dv equal to a times dt. Suppose motion with uniform acceleration, a. For that case, dv equal to a times dt. So if you integrate from say 0 to t, and then if you integrate from u to v, that means at time 0, at time t equal to 0, that is, you call it the initial condition. That means when you start calculating the time, or you set your stopwatch to 0, velocity that is, it is known as the initial velocity is equal to u, and v is velocity at any time t. So here, after integrating, what you get? V inside box, so u to v, here a t, 0 to t, that means here you get v minus u equal to a into t minus 0. Therefore v equal to u plus at. And obviously you know that v is dx by dt, so dx is equal to v times dt. So therefore, so integration of dx equal to integration of v, you can put here u plus at times dt. Now say at time t equal to 0, the coordinate was x naught. So at t equal to 0, coordinate equal to x naught, and at t equal to t, coordinate is equal to x. So actually this is a particle at t equal to 0, this is at t equal to t. So from a certain, so this is the these are the coordinates x naught and x at the different time. So this s means the displacement from time 0 to time t. Okay, so here what you get, x minus x naught equal to, see, u dt integration 0 to t plus a integration t dt from 0 to t. So this is s equal to u, there you have 0 to t plus this is t square by 2, this 2 you can bring here, so t square from 0 to t. Now u t minus 0 plus a by 2 t square minus 0 square, right? So therefore you get s equal to ut plus half a t square, or you can keep it like this, x equal to x naught plus ut plus half a t square. This is in terms of the displacement, and this is in terms of the coordinates. X minus x naught is equal to s. So graphically also, you know, graphically this velocity, say if you have the vt curve, here it is obviously a straight line, so the integration, so integration of v dt from 0 to t, that is s. So that is from the integration concept, you know, the area under vt curve from here to here. So you can calculate it from here also. So this is u and this is v. So s is actually equal to the area of the trapezium, so that is t. So half of sum of the parallel sides u plus v multiplied by distance t. So here you can put u plus at times t. So s equal to here ut plus half a t square. This is for constant acceleration. If it is not constant, so it will be that case only. Suppose if v varies with time like this, so it will be this much area. Okay. Now it may be negative also. Suppose this v varies with time like this. Suppose you have to calculate the displacement of particle from 0 to t. So this is certain area, say a1, and this is say A2 some area. So here from 0 to t, the displacement s is equal to a1, and there will be minus sign for this, a1 minus a2. Why minus? Because see here v is 0 and here v is negative, so particle is turning backwards, right? So it goes, so it's like this, it goes a displacement here a1 and returns back a2. So resultant displacement is a1 minus a2. By the way, that if you encounter such problems, you can deal with. Okay. And the area under the acceleration time curve, as we know from the concept of calculus, suppose this is AT curve. So in general, I am talking about say T1 to T2, right? So you know, see acceleration. So a dt is equal to dv. So integration, even if a is not constant. So suppose v1 to v2, there you put t1 to t2. So v2 minus v1 is integration of a dt from t1 to t2. So the area under the acceleration time curve from t1 to t2 is equal to the change in velocity. The change in velocity v2 minus v1 from time t1 to t2. For constant acceleration, obviously a will be constant, it will be flat. There it is, na? For constant acceleration or uniform acceleration, this is a. So from time 0 to time t, this is at, right? So v minus u, v is velocity at time t, and at time 0 velocity is equal to u, so v minus u equal to at. So v equal to u plus at, looking at it from a different way. Now, so let us go back to constant acceleration motion for uniform acceleration motion. Uniform acceleration motion, obviously in a straight line, we have got two equations, v equal to u plus at, and then the next equation was for displacement, s equal to ut plus half at square, and if you square this both sides, v square equal to u plus at whole square. So let's see, u square plus a square t square plus 2u at. So you can write 2a common, then you get ut plus half a t square. So that is u square plus 2as. So you get one more equation, v square equal to u square plus 2as. So basically we have three equations to deal with problems on one-dimensional motion. You could have reached in this equation from a different way. So here I am showing a proof, again an alternating proof, looks like this. So you know a equal to dv dt, so dv by you can write ds into ds by dt. So you know that is a chain rule. So again this ds by dt is v, this part is v, so the v dv by ds. Okay, so therefore a multiplied with ds equal to v times dv. So now integrate with limits. Here as this a is constant, it will go outside integration. So obviously it's for displacement, not for coordinates. So at time 0 it is 0, time t it is s. At time 0 velocity is u. When velocity is u, displacement is 0. When velocity is v, displacement is s. So a s equal to half of v square minus u square. So you get this v square equal to u square plus 2as. And also we will come across one more equation, that is displacement during the nth second of motion. Displacement during nth second of motion. So what is the nth second of motion? See, what is the first second of motion? Let's see. First second is from t equal to 0 to t equal to 1. Second of motion is from t equal to 1 to t equal to 2. So in the same way, so nth second is from t equal to n minus 1 to t equal to n. So displacement during nth second is displacement during n seconds minus displacement during n minus 1 seconds. So here I will put here u, in place of t I will put n, un plus half a n square minus u n minus 1 plus half a n minus 1 square. Okay, so that will be u plus half a c n square minus, so there will be 2n minus 1. So this is the formula for displacement of a particle during the nth second of motion. Now you can also apply this in case of motion under gravity, because motion under gravity is motion under uniform acceleration. Gravity acts downwards always. Okay, so let's take up some problems. Problems on 1D motion with uniform acceleration. And also one more thing you have to note, that the VT curve. So VT curve, if you have a VT curve like this, and if you have a displacement time or coordinate time graph like this only, so the tangent to the VT curve at a point will give you what? Velocity. No, sorry, tangent to the VT curve at this point, the slope of tangent, so this makes theta. So tan theta is dv by dt equal to a, and if this is s displacement, then say this is for phi. So here tan phi is equal to this, ts by dt is equal to v. So we'll discuss more problems on graphs. Okay, first let us discuss some problems on 1D motion. I mean, without graph problems, then we'll come back to graphs. So problem number 1, here it's given that there is a, we'll start with a motion under gravity problem. Okay, and this acceleration due to gravity is downwards, and downwards g is equal to 10 meter per second square. Problem is like this. Say a particle is dropped from a building of height h. Now find time taken to reach ground. First question. then speed with which it hits the ground, next displacement during the last 2 seconds of its fall. So it's already provided that it takes more than 2 seconds. 2 seconds to reach ground, else it doesn't make any sense. So this is the problem. So here there are some techniques for solving problems, we will use the three equations, basically the three equation. Which three equation? S equal to ut plus half at square, S equal to ut plus half at square, then v equal to u plus at, and then v square equal to u square plus 2s. Now this u, v, a all are vectors. So first we have to choose a 0 of the coordinate system. Suppose we choose origin of the coordinate system or 0 of the coordinate system, and we have to choose a direction. Say I choose this as the positive direction. This is important, or else how will you assign the signs to u, v, a and s, whatever? If you don't choose a direction and a 0, you cannot write about s or the signs of u, v, s and a. All are vector quantities. So this is positive direction. Obviously we won't use vector notations now because all are in the same direction. Okay, so now with respect to this problem, see this g, so acceleration due to gravity is g, which is 10 meter per second square, always downwards. So find time taken to reach ground. So here we have chosen the 0 and here you have chosen the positive direction. Now ball is dropped from building. So meaning of dropped is that the initial velocity is 0. First I'll set up the problem, right? So u is equal to 0, it's given. And what about a? A is equal to g, or a is equal to 10, whatever. And if suppose height is given here only h, so a is g, g is equal to 10, and we'll keep it here as g only. So time taken to reach ground. Okay, so for solving this first part, time taken to reach ground, see which will be the equation you will apply, and out of these three, obviously you will apply the first equation, because when it reaches ground, suppose it reaches ground in time t, you know the value of s. From here to here displacement is h, so I'll put here s equal to h time t. So therefore h equal to, for u 0, 0t plus half gt square. So therefore t equal to root over of 2h by g. So this is the time taken to reach ground. Now the speed with which it hits ground. So part B, the speed with which it hits ground. You can apply this as you have calculated the time t. You can use so 0 plus a is g into root over of 2h by g. So that is root over of 2gh. So v is equal to root over of 2gh. And also you could have used the third equation, right? This v square equal to u square plus 2as, because see from the starting point here it goes downward positive. This is a 0 of this coordinate system. So u, when it reaches ground, s is equal to h, u is equal to 0. Now question mark on v, and a is equal to g. So here v square equal to 0 square plus 2gh, so you get v equal to root over of 2gh. In either way you can solve it. And what was the third part? Third part is displacement during the last 2 seconds of fall. So displacement in last 2 seconds is how much? So it's displacement in t seconds. I mean t is time of fall, right? T is total time to fall, 3 seconds, minus displacement in t minus 2 seconds. So that is equal to displacement in t seconds is obviously it's h, minus displacement is in t minus 2 seconds is half g t minus 2 square. So I'll just put the value of t here, half g by 2 root over of 2h by g minus 2 square, and hence you can calculate this. Now the next problem we'll take up is, here instead of dropping the particle is thrown up from ground here with a speed u, and say I'll give some values. So suppose it is 20 meter per second. So particle is thrown up from ground at speed u, 20 meter per second. Find time to reach maximum height. Second, the maximum height reached. Third, the times at which it reaches half of maximum height. Okay, next one part also, the total time of flight. Some more, the displacement and distance covered in 1 second and 3 seconds from when it's thrown up, from the moment it's thrown up. Okay, from the moment it is thrown up. So many questions in one. Particle is thrown up from ground at speed u, and obviously this is g, acceleration due to gravity g. It happens to be 10 meter per second square. First question was the time to reach maximum height. See, is there. So you have to choose the 0. This is the 0 of the coordinate system. Suppose this is the positive direction. So there it is, u is 20 and a is equal to, as I have chosen the direction upward positive, so a is minus g, or that is minus 10. Okay, so time to reach maximum height. So when it is thrown at maximum height, when it reaches the maximum height, then its velocity is equal to 0. So at the maximum height, velocity is equal to 0. So time to reach maximum height, suppose t is the time to reach maximum height, so I'll use this equation v equal to u plus at. So I'll put v as 0, u as u, so 0 equal to u minus gt, so t is equal to u by g, or here as the values are given, u is equal to plus 20 and a is equal to minus 10. So the time to reach maximum height becomes 2 seconds. 20 by 10 is equal to 2 seconds. Okay. Second part, maximum height reached. Okay. So you can apply s equal to ut plus half at square, or I will apply this rather, v square equal to u square plus 2s. So at maximum height, v is equal to 0 and s is equal to h. From here to here, displacement is h. Obviously a is minus g, so 0 square equal to u square minus 2gh, so h is equal to u square divided by 2g. This you can remember also as a formula, and or in this case, u is equal to, u is plus 20 and a is minus 10. So if you put the values here, u square, so h is equal to, h comes out to be 20 into 20 by 2 into 10, so that height is equal to 20 meter. U square by 2g, right? 400 by 20 means 20 meter. Okay. Now next, time at which it reaches half of maximum height. Okay. Now see, obviously time at which it is half of maximum height, there will be two values of time. So h, put it h by 2, and see, you have chosen the 0 here and the axis here upwards, so you will put s equal to h by 2, that is the maximum height came out to be 20, so that's 10, and you will apply s equal to ut plus half a t square. I can put here 10 equal to u is plus 20 t minus 5t square, therefore 5t square minus 20t plus 10 is equal to 0, t square minus 40 plus 2 is equal to 0. So obviously you will get a quadratic equation. As you have got a quadratic equation, there it makes sense, because the displacement is this half of the height, it is at 2 times while it is going up and while it is coming down. So we will solve and get two values of time. So you will apply this formula, this is b plus minus root over of b square minus 4ac by 2a. Let's see, 4 plus minus, that becomes 16 minus 8, so 8 divided by 2, so t 4 plus minus 2 root 2 divided by 2, therefore t equal to 2 plus minus root 2. So there are two values of time, that is 2 minus root 2 and 2 plus root 2. 2 minus root 2 while going up, 2 plus root 2 from start, 2 minus root 2 while going up, 2 plus root 2 while it goes up, coming down. At this point, this whole time from here to here takes 2 plus root 2 seconds. Okay. So part C done, there is part D and part D. E. Part D, total time of flight. Okay. See, intuitively you can tell, or you can also prove it, that time to go up is equal to time to come down. So total time of flight t is equal to twice u by g. or that is here it is 2 into 20 by 10, that is 4 seconds. 2 seconds to go up and 2 seconds to come down. Or you can use this formula also, s equal to ut plus half at square. S stands for displacement, you know, so when it comes back to the same point, displacement is 0. So I'll put here 0 and 20t minus 5t square implies so what do you get here? 4t minus t square is equal to 0. That's also a quadratic equation. You have t into 4 minus t is equal to 0. So you get two solutions. One is t equal to 0, another is t equal to 4. This is obviously true. T equal to 0 means while just it is being thrown up, obviously displacement is 0, it has just started, and while it comes back to the same point, t is equal to 4. Total time taken is 4 seconds. And in many books you will find the solution like this. So it goes up to a point, then from this point they choose a separate axis. So they choose a separate 0 and choose a separate axis downwards. So from here to here you calculate the time. So from here you start a new problem from here. So here you choose the velocity is equal to 0. So u is equal to 0 and a, as the axis is downwards, you choose a equal to 10, that is plus 10 or plus g, and hence h equal to 0 times t plus half 10 times t square. So so h was 20, it was calculated before. So t is equal to 2 seconds. This is for the second half, right? Going up, so from here, again from here to here, so it becomes the same as problem number 1, right? Say a particle is dropped from a height of capital H, which 20 meter, which came out to be 20 meter, which is the answer to part B, maximum height reached. Then it's beginning a new problem, but we now we know that it's not required actually. Once you choose the 0 and the axis, you can stick to your commitment. I mean, while in between the same problem, there is no need to change the axis and the coordinate system. Okay, that's a part D done. So part E was displacement and distance covered in 1 second and 3 seconds. So it's going up, coming down. So there it's time t equal to 0, it's thrown up. This is time 2. So during 1 second and 3 seconds, obviously during 1 second it's going up, see, and during 3 seconds it's coming down. So see the gap from, if this is t equal to 1, so 1 to 2 is a gap of 1 second. So I'll going up for 1 second, and 2 to 3 is 1 second. So 1 second to go up and 1 second to come down, obviously t equal to 3. So you can verify also from the equation. Suppose I choose here the 0 and here the axis, it should be here actually, the point where it is thrown. So we'll just apply s equal to ut plus half at square. So you put here u is equal to 20, a equal to minus 10. So s equal to 20t minus 5t square. Now you put here at time t equal to 1 second, s is equal to 20 minus 5, that's 15 meter, and t equal to 3 second, s equal to 20 into 3 minus 5 times 3 square is 9, so that will also come out to be 15 meter. So it shows that the displacement is same, 15 meter, and obviously we have calculated previously this 20 meter maximum height. So in 1 second displacement is equal to 15 meter and distance is same 15 meter, but in 3 second displacement is equal to 15 meter. This you get from here. S is the formula for displacement, while distance you know it is it goes up 20 and then this gap is 5 meter, so distance is equal to 25 meter. Problem number 2. Then problem number 3. See, here you have a building of height say 20 meter, and from the top of this building a particle is thrown up at say 20 meter per second. So from a top of building, 20 meter high building, a particle is thrown up at 20 meter per second. Now find time taken to reach ground. Time taken by particle to reach ground, and also find velocity or speed, rather speed with which it hits ground. Okay, so here also you have to choose, as usual with all problems, you have to choose a 0 or the coordinate system. So I'll choose a 0 here, and the axis you can choose either downward or upward, your choice. For this problem I will choose it upwards positive. Okay, so you know acceleration due to gravity g downward, it's 10 meter per second square. Unless mentioned, we can take it as 10 here. Competitive exams, they will all mention the value of g to be 10 in the paper. Okay, so first one was find time taken to reach ground. I'll use this formula, s equal to ut plus half at square. As I have chosen the axis, this u will be equal to plus 20 and a will be equal to minus 10, and when it hits ground, what is the displacement? Displacement is the line joining the starting point and the end point. So initial position or the starting point, this is the end point. Wherever it changes, it goes there, up, comes down, but displacement is downward. Displacement is equal to minus 20 with respect to the positive axis chosen upward. So I'll put here minus 20 equal to 20t minus 5t square. So divide by 5, minus 4 equal to 40 minus t square. So t square minus 40 minus 4 is equal to 0. So this was the equation, t square minus 40 minus 4 is equal to 0. So t, by solving this quadratic equation, you get t is these two values of time. So you know this value is true, 2 plus 2 root 2 second, and speed on reaching ground, as in the problem it was tower, it was thrown up from the tower and what is the speed on reaching ground. So you can get it like this: v equal to u plus at. We can keep the axis here as we have chosen upward positive and the 0 here. So v equal to, so u is plus 20 and a is minus 10. So after substituting you get v is minus 20 root 2. That means the speed is 20 root 2 meter per second, and negative sign shows that it goes downwards. Also you can solve it by this. So this was 20 meter, so you know v square equal to u square plus 2as. So this v is not known, so here v equal to u 20 square plus 2a. So if you want you can keep the axis here, plus 2a is minus 10 and s is minus 20, right? S is minus 20. That is how you get the same answer, 20. This is so v will come out to be 20 root 2. Or if you want you can choose the axis downwards and you get plus 10 here and plus 20 here.